I think that with respect to the syntax elements of template code, I think the next very important thing for us is to be able to specify an overloaded operator for cout or other types of output streams, so that we can simply display the content of the container just like this. Just use this container and say that we want to be able to print all elements, possibly separated by spaces, and send them to cout. Well, if you recall the way we approached it in a string class in our prior presentations, we've tried something like this. We said let's use standard output stream, and reference is returned by operator output, and so this operator output is the name of the function which will be invoked for cout and for cout and this container, right? So we're talking about this situation where we combining cout and container together using this operator. So the compiler will attempt to search for this function with such a strange name, operator. So let's give this a try. I'm doing exactly what we did with our string. So ostream output stream, which is the type of cout right here, and it's passed into this function by reference ostr. So that's the left hand side of this operator. Cout becomes output stream right here. And on the other hand, on the other side, on the right hand side, of course, we can use just like we did with our copy constructor. We could take this type of parameter to specify the fact that we're trying to print this object. So I copy this and make it a second parameter. Well, now I think I will have to start using more of my real estate on my screen right here. So this will be the idea. Then we can provide the definition for this function. And I think again I can try to use this type of for statement to create a loop and basically go through the container size of our container, increment index, and basically just here we can use this reference to stream and print to it by using this formatted output and add space. Okay, so for now that's the idea. Okay, however, this instantly requires that this operator must become a template, right? So just like everything else we did with this class, we have to define this function with the template prefix by somehow telling compiler that this thing is coming from the idea that we have a template class, and it will provide the value t. Okay, so we'll give this a try for now. Now, also for this to be able to compile, for this code to compile, we need to return back a reference to output stream. So this is trivial. We just simply return ostr. Okay, so this is how most of, in general, that's the look and feel for overloaded operator to use with our stream, and that's fine. Okay, so now there is one more thing to do. Another is a reference, so we need to say that it's the storage that we're trying to access. So this is just a starting point. The idea is to somehow define an operator like this. All right, so we may still have some unanswered issues, and we're really trying to make sure that this code works. Let me comment this out for a second, okay, and just build this. The problem that we're having here is the container size. So the container size, right? So container size is unknown. So container size we could potentially specify as basically it's a static integer that sits inside our container class. So therefore something like this, using the scope resolution operator of the class, right? Try to tell the compiler, let's use this type of container size. Okay, so we build this and it builds fine. Okay, so that's interesting observation. The next step is to bring back the actual attempt to print something, right? So we want to be able to run this loop through every single element in our storage in our class, and just keep printing all of them. So let's try building it this time. And we get this new message right here that all of a sudden container size is a private member static variable, but it's a private static variable inside our class. Okay, so this is it's being declared in a class as a private. You know that everything by default is private inside this class container. So once again, with a string definition that we tried with our prior successful result overloading this operator, we simply took the declaration of this operator function, and we copied and pasted it into the body of the class with a friend qualifier. In other words, this operator should be allowed to access private data members of class containers. So that's the idea of a friend. Okay, so we save this, and generally following the steps of the previous class that we tried to build. So now we have a friend declaration. We also have this, in fact, I will move this operator closer to the class definition so that when I have to do less scrolling on my screen. Okay, right? So we're trying to use this idea of an operator. Now we decided to make it a friend. Now we're deciding to build it. So what we're running into is that it's really obscure error message. It's not even compiler error, it's the linker error. The linker is trying to basically locate a function definition for this operator, and mysteriously it's not finding it. It just tells us that when you see that linker says something unresolved and it's with respect to some sort of function like this, it is the thing is that something is unresolved. And I'm not going to spend a lot of time talking about this error. I will give you a clue. And in general, template error messages can be very cryptic and can be very difficult to parse and determine in what direction you need to move with this message. Especially compiler did not give us any errors, and the linker gave us errors. So compiler thought that it was able to go through the code, but in reality things got disconnected. And so the answer to this is that this operator uses template, and this friend is not a template. So the syntax for friend definition of this operator is to use this type of diamond thing. Basically, it says that, yeah, I know how cryptic the syntax really is. This now becomes a bit overwhelming, but what can we do? That's the syntax, and we have to be able to navigate through it. So right here, we're saying that this operator is a template. Now, you might say, but we are already sitting inside the template, so how come we need to worry about something else? Because of the friend. Friend is always friend never makes whatever it tells you will be a friend. The friend does not make this portion of our code part of class container. It's only trying to message compiler that, okay, we're expecting some function which isn't even defined yet. It will be defined at some point, but we'd like to allow that function to access private data members here, and this is all friend does. So by making something friend inside class container, it doesn't automatically convert this something that we're trying to add with friend part of that container. It's really like multi-layer set of abstractions. But what can we do? So anyway, so the secret, if you look up in the book how to do this, we will realize that this is a template. Okay, so this is kind of strange little syntax that we have to provide here. This kind of diamond-shaped combination. And I save it, and again pressing the build option to build. So now my next message is here, and it says another extremely cryptic error message. And it says missing semicolon before this. So in other words, it was expecting this to be over by now, like with the semicolon or something, and yet it encounters something that just doesn't make sense. Okay, so we need another explanation for this next stage. And the explanation is that this friend has no clue that this is a template, so it just doesn't know how to convert something that looks to friend as a non-template and make it a template. Okay, so strange thing. In other words, we need to take this. Okay, we need to take this is good. This has no problem. Compiler can understand what is happening right here with our operator and all the parameters and the fact that it's parameterized by some value type and all this, right? So we need to take this and make it a declaration and declare it first. So now compiler should know that this operator is part of the template workmanship. Okay, so so of course I just added semicolon, so I sort of like duplicated the signature of this operator, declared it before anything else, and added the semicolon to it. Okay, build, next attempt. Now it just tells us I have no clue what container is. You didn't tell me anything. So we have a chicken and egg problem. We're trying to declare this operator because we're trying to to convince this friend within this class that this thing is somehow parameterized by some kind of value type. And on the other side of things, we're trying to do it before class container, and compiler now complains that it doesn't know what container is. So the next step is to forward declare. That's kind of another part of technicality right here. Let me close this to keep more of the code in view here. So we need to say forward declare class, right? Class, and we can say template class or just class container. Okay, so we need to take this thing with this stubborn value t that persists everywhere now, and forward declare it. How we do this? So we simply take this, okay, and copy it and paste it over here, and tell the compiler now that when you see something like this, don't panic. It's a class, and it's a template class, and it will be parameterized. It's a promise that it will be found someplace, and it will be parameterized by value t. So now it should know what this is, then it should know what this is, and then we should be able to allow friend to finally recognize what is the attempt here, and what exactly are we trying to make a friend, this function, okay, which here has only declaration. And by the way, the definition also, this definition wouldn't work at all, because the storage is still haven't been defined. So we cannot just take this definition of the function and move it to the top before container, because the compiler still doesn't know what this is, and it still will not be able to build anything. Okay, so with this in mind, forward declare class container, then declare the signature of the operator, which is in itself as a template function, and now define the container, trying to convince compiler that it's okay to use all of the variables within this operator, and finally provide the definition. So save this and build it. And suddenly this passes the test, and you see that we're now made some progress with this. And let's see if we actually are able to print something. Somewhere here I said that let's use it. Control F5 to run the application, and we get this a little bit of a strange looking output on our screen. I will try to resize it to make it a little bit more. I guess I can rerun it. All right, yeah, I need to resize it even larger size. Rerun it again. No, it doesn't stick. But the container is populated with, if you take a look at the definition of our container, I'll just bring it to the view. Okay, so the storage here that we're trying to print, each single element of this array of 10 elements, is printed inside the loop, and this is the loop right here, index 0 through container size, which is 10. We simply print all of the elements right here, and these are garbage values. Why? Because I intentionally kept default constructor empty. So when we allocate this array of 10 elements, it just grabs some memory, whichever memory is available, whichever memory happens to be in place, and starts using it. So in reality, this array of elements does not have any initializer, and our default constructor, this constructor, does absolutely nothing. So again, to keep things in better shape, I think what we can do in this section to complete this little demo of operator and make it look a little bit better. We can copy this loop one more time. I guess I can copy the entire thing and just quickly place it here. And what I'd like to do is I'd like to initialize this. Every element I would like to initialize with what? In case of doubles, I want to initialize them with zeros. In case if this is container of integers, I want to also initialize them with zeros. If it's container of strings, I'd like to use maybe an empty string to initialize every element of this container. So what can we do? We simply don't have zeros or empty strings. We have value t. So we will say that in order for elements to be inserted, items to be inserted into the storage, they have to support default constructor. Okay, so they have to provide default constructor. So that's a requirement on the type which can be stored in our little demo storage. And this is the syntax. You use the constructor syntax for this. And basically, if you write a code like this, int with empty parentheses, like and constructor syntax, each primitive data type has a default value. Integers, characters, all integral data types, doubles, they all define to have default value 0. Okay, so let's try this our second time. So build, okay, and run it again. So let's see what kind of output we're expecting. We will be printing 50, then we should be printing everything in the container. Okay, okay, so here, so this time this line here produced zeros. Okay, and then, and let's see, so this is element 0, 1, 2, 3, 4, 5, right? So this is the 5th position in our storage. And then remaining elements are also 0, because now the default constructor took care of these garbage values and reinitialized them with the default values for the double type. And this, and you can see that the default values for the double type are zeros.